Greetings, everybody. Hello, 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 and welcome back. Thank you for tuning in. Um, welcome to lesson 7. So, in this lesson, we're just going to do it empirical formula. So, it's a short question here on empirical formula. We are still doing chemical change, isn't it? So, I have a short question here about empirical formula. So, this is where we are still using the table. So, it comes from where? This question comes from. So November 2023, KZN. Okay, this is November 2023, KZN. So let's read the question. They say what? A compound contains 30.4% nitrogen and 69.6% oxygen by mass. Define. So the 6.1, they want the definition. Define the term empirical formula. What is that? This is the simplest whole number ratio. This is the simplest the simplest whole number ratio of atoms in a compound. This is the definition for empirical formula. Now they say determine the empirical formula of the compound. Say this is where we must use the table. So 6.2, determine the empirical formula of the compound. So we draw the table here. And people, you should know the table by heart, okay? The table is not given in the exam, so it should be known. You should know how to draw the table. So there is element, okay? There is element, and then there is G over 100G. G over 100G, which is going to be your percentage here. So the percentages come in this column here. And then the next column is your number of moles. N equals to M divided by capital M, the molar mass from the periodic table. And then after that, we have the simplest ratio. Simplest ratio. So, so we're going to have two rows in this case because we only have two elements, isn't it? They gave us two elements only. So they gave us nitrogen and oxygen. So it's going to be only two rows, but the number of rows depends on the elements that you have. So it's N and then this O. And then the percentage here is what? 30.4 for nitrogen and 69.6 for oxygen. Okay. Then we come here. So the numbers here, these numbers will go on top. Okay. So the 30.4 here. So we say 30.4, and then we said 69.4. So you use a calculator here. So it gives me 2.17. And then over here, 69.4. And we divide by 16. It gives me 4.35. See? And then 4.35. So these numbers here, again, they go on top. Okay. So even that 4.35 will go on top. 4.35. Then how do we get the simplest ratio? We look at the numbers here, number of moles, and then we divide by the smallest. You see? So we divide by the smallest number. We have 4.35 and we have 2.17. So it means this is the smallest number over here. So we divide by the smallest number everywhere. 2.17, 2.17. So here we get 1, here we get 2. Then, so the simplest ratio is 1 and 2. So it means that what? Therefore, the empirical formula is, therefore, the empirical formula is the empirical formula so N1O2, or you can say, if there's a 1, we don't write down the subscript. So it means that the empirical formula is going to be NO2, like this. So this is our empirical formula. Yes, and then 6.3, what are they looking for? They say, write down the molecular formula of the compound if the molecular mass of the compound is 92. Okay. The molecular formula of the compound is 92. So 6.3, we're going to say and we use our formula. EF equals to M. So it means that N will be equal to M, and then EF divided by EF. So it's going to be, so we use the empirical formula here, EF. So the EF is going to be 1 times 14, 1 multiplied by 14 plus 2 multiplied by 16. And then we use the molecular mass. Then, so it's going to be 92 divided by 14 plus 32. That is 46. So it's going to give us 2. So we multiply by 2 here. We go to the empirical formula and we multiply by n. So 1 multiplied by 2, and then 2 multiplied by 2 again. We multiply by 2. So it means, therefore, you, yes, therefore, the molecular formula O4. N2O4, we get it from here. So it's a short question. Okay, wasn't long. So yeah, so that's it for this question. Let's leave it here, okay? So leave your questions in the comments section again, and let us, I hope you tune in for lesson 8, okay? I'll bring another question for lesson 8. So let's leave it here for lesson 7. Thank you for tuning in.